Do you know what pH is?
No, what's pH?
I'm glad you asked. To start, pH is a measure of how basic or acidic a solution or substance is. The pH scale ranges from 0 to 14. The value of 7 indicates neutrality, meaning the substance is neither basic nor acidic. An example of it is that water is neutral.
Values 0 to 6 indicate an acidic substance, with 0 being the most acidic on the scale. And similarly, 8 to 14 indicate a basic substance, with 14 being the highest value of basic character.
Karina, but what does basic and acidic even mean?
Good question. Let us explain. Well, pH stands for potential of hydrogen. Every solution has a certain concentration of free hydrogen ions. A substance is more acidic if more hydrogen ions are present, and more basic the less hydrogen ions present.
Acidity refers to the strength of an acid or how easily that substance can release hydrogen-positive ions. Acid solutions can break down substances because they react easily with other metals and then donate some of its hydrogen ions.
If you think of acid, you probably think of sour candies, lemons, or acid rain in sci-fi movies that melt skin off, which is accurate in extremely low pH solutions. Acids are known for breaking down substances due to this donation of hydrogen ions. This reaction weakens chemical bonds, breaking them down. This process is called acidic corrosion or decomposition.
Acidic corrosion is a reaction with metals and minerals, gradually wearing them away.
And acidic decomposition is a breaking down of complex substances into simpler ones.
Now, let's talk about basic substances.
Basic substances have more hydroxide ions. They're more bitter and slippery. Think baking soda or soap.
They can accept hydrogen ions or donate hydroxide ions when dissolved in water.
Bases can also react with acids to form salts during a neutralization reaction. They produce acidity and help the substance reach a more neutral complexion, like water. And they can also break down substances and maintain a balance in different systems.
pH is part of our everyday life, even if we don't realize it. It affects the food, and it affects the drinks we ingest and our human health. How does it affect our food and drinks?
Good question. Let's explain that too. pH can influence the flavor of foods. Acidic foods such as citrus fruits and vinegar, which have a sour taste, have a lower pH, while alkaline foods such as certain vegetables, nuts, and seeds, which have a bitter taste, contain higher pH.
pH also helps with the preservation and spoilage of food. Foods with lower pH such as pickles, yogurt, and fermented foods resist bacterial growth and spoilage, helping them last longer. However, foods with higher pH spoil faster and might require refrigeration.
With all this said, you might ask yourself,
How does it affect my body?
pH affects our digestions and metabolism. For example, acidic foods stimulate our stomach acid production, which is highly beneficial for our digestions since it breaks down food, activating the digestive enzymes and acting as a barrier against harmful microorganisms. While too much acidity can lead to irritation of your stomach lining, causing reflux or ulcers.
Karina, do you ever wonder if pH in our cleaning supply that we're using right now?
First, pH is in everything, even in our cleaning supply.
Really? Let's break it down. Acidic cleaners, which have a lower pH, are great for removing hard water stains, rust, and mineral deposits. Think about toilet bowl cleaners or vinegar-based sprays.
That's because acidic solutions can dissolve mineral buildup. So when your sink is looking all crusty and gross, those hydrogen ions go to work breaking it down.
On the flip side, basic cleaners, which have a higher pH, are more effective on grease, oil, and general grime. Stuff like bleach, ammonia, or baking soda-based cleaner.
Basic solutions break down organic materials, like fats and oils, by reacting with them and making them easier to wash away. That's why soap feels slippery and slightly basic.
So the next time you're scrubbing your bathroom or wiping your kitchen, just remember you're doing chemistry! From our food to our stomach and even our cleaning supplies, pH plays a huge role in how things work around us.
Acids and bases aren't just in the lab, they're part of real life.
Whether it's breaking down grease or helping food last longer, pH is kind of a behind-the-scenes MVP.
And now, You're in on the secret.
Karina, we did such a great job. High five!
Thanks for watching!